Hello, good day from Sudhanshu. In this video, I will try to explain what is superposition in quantum computing. That is, we have quantum computing code to write, and we will examine how to reach superposition and evaluate the result of superposition and why it is important. First of all, if we generate a generic program, that is, create a program to add or to add two numbers. Okay, so we will simply generate the program. This is how classical computers work. It is asking for two inputs, let's say 5 and 5. 10 should be the answer. So we are having a predictive solution here that 10 is the total answer that we get. This is how classical computers work, where output can be predicted. Even the randomness of the program can be predicted, okay, in the classical computers. Until and unless external environment input is there. Now I will come to the point where superposition comes in. Let's say if we want to have an encryption key for the security reasons, where we do not want to determine how much would be the value of the output, in that scenario superposition rules come in, and this is calculatable once the probability is there 50-50 that we cannot determine what should be the output. Only then it is useful for the encryption purposes and security of the data. So let's understand. Program example for superposition. I will explain what is superposition in a minute. Just a moment. Okay. As you can see, the code has been generated. In this code, we are first using a qubit. That is, we are simply defining a qubit. The qubit has been declared. Use q as qubit. Okay. This is a C sharp code. Q sharp code, sorry. Once the qubit has been generated, then we apply Hadamard gate. Hadamard gate to the qubit. Initially, we made it first qubit, otherwise it would resemble a classical bit which can only be 0 and 1. But because now we have defined it as qubit, it can be 0 or 1 at the same time. That means it can hold two values. In classical computers, only 0 or 1, either of the value will be constructed. In this scenario, because we have used qubit, 0 and 1 together can be the state of the qubit. Now once we do that, we have applied the Hadamard gate, and now we want to measure what would be the output. To measure the result, to result either it will be 0 or 1. This is unpredictability. So we are applying M. M stands for measurement. Measure the qubit, Q which has been Hadamard, that is sent into the superposition state. So now we'll see the execution result with the explanation. Here it is. So what happens is the output is 0. Let's see the actual explanation. A qubit was initialized with the 0 state. Okay. The Hadamard gate transforms this into the equal superposition of 0 and 1. This means there is a 50% chance of measurement being 0 and 50% chance of measurement being 1. The qubit starts in the 0 state. Now where have we defined that qubit should be in the 0 state? Or it's always in the 0 state once it is declared like this. Let's write a program for this to check output. Okay, so we have this example here where q is equal to qubit and measuring the qubit and show the result. Okay, let's execute. It's a simple code. Simple code says the new qubit is allocated in q sharp Newly allocated bit are always initialized in their ground state, which represents 0 basically. So the measuring result of the Q, since Q is deterministically in the 0 state, its measurement will always yield the 0. Okay. So the initial state is always 0. Hence we conclude that if the superposition, that is Hemgard, now if we apply something like this, let me write the overall program. Let's apply Hadamard gate, which elevates this qubit into superposition, and then let's show the result. Result can be shown as mm, result, return result, return result, which will be, let's first measure the Hadamard qubit. M measure qubit, that means collapsing the result. With collapse we mean to say, let's give us the one value, whether it is 0 or 1. This is something which is unpredictable, so measurement is there only. That super, once it has to be sent in the superposition, the measurement will come out to be unpredictable. If I eliminate this part of the code, then it will not go into the 0 and 1 position together, and we would get the same output. So let's measure the output qubit, and then after measuring the qubit, we will have a return, and let's store it in the use result as equal to like this, and let's have result as the output. Okay, make program out of it, press the enter key. Let's get to the program. Let's see the execution. So as we can see, the qubit performs the following step: allocates a qubit. Qubit is initialized in its 0 state. Applies the Hadamard gate. Hadamard gate elevates it to the superposition. This can be represented as 0 plus 1 and square root 2 divided by measurement of the qubit. The measuring the operation observes the qubit state. Due to superposition, the measurement has a 50% chance of collapsing it into 0 and 50% chance of collapsing it into 1. Resulting the result, our result outcome measures 0 is 1 is returned. Simulation output, simulated output. The simulated output will produce either 0 or 1. Each outcome has 50% probability. Therefore, a single run of simulation can yield one of these two results chosen probabilistically. Okay. The qubit has the following steps. How to show the result. Show result. Complete the program with output. So what I'm going to do now is, every time I execute this program, it should give unpredictable result. That means it can be same or it cannot be same. That means 0 will be there or 1 will be there. So if this time 0 has come as the output, let's execute it once more. Just read the code. Execute again. So I'm gonna give the same program 2-3 attempts to see whether if we get the value of 1, because each time the superposition is being applied. Okay, this time the output of the program is where is the output? Initialization happens, and then it also 0 also represents the off state as written over here. into the superposition state, both 0 and 1, measuring it, collapsing it into will be 0 if it collapses into 1. Since the output is the program will present the measurement results. Similarly, the output. Okay. So we should have the output this time. Measure results in 0. So as you can see, it has not given the 1 value for my head mart position, and I'm wondering if we ever get that value. Let's execute the program again. Output is 0. What I'm going to do is I'm going to execute 10 outputs of this program. So I'm going to get 10 times the value of this program. So 10 values would be there. Let's see how many of them are 0 and how many of them are 1, or whether it's all 0. So it's becoming 0 1 0 1 0. So this is the pattern. This pattern can be used in the programming for security reasons. Well, this is all I wanted to convey. We are able to get 1 as the output under the second time the code executes. Have a good day. Bye bye.